Well, here we are on 11.5 notes. We are looking at the quotient rule. This is another rule that will allow you to find derivatives of functions. And this rule is going to apply when you have a function divided by a function. Okay, so look at example 1 here real quick, just glance down to there. I mean, you've got a function on the top, a linear function on the top, divided by a quadratic function on the bottom. That's usually when you're going to want to apply the quotient rule to find the derivative, is when you have a function divided by a function. Okay, so the quotient rule is low d high minus high d low, square the bottom, and away we go. It's a good way to remember it. I'll say that slower. Low d high minus high d low, square the bottom, and away we go. All right, so if you look at the rule, when you are taking of a function divided by a function, you just write down the bottom function, low, and then you do the derivative of the top function, d high. And then it's minus the high function, the top function, just write it down, times the derivative of the bottom function. That would be high d low. Okay? And then it's over the bottom squared. Square the bottom, and away we go. All right, so that's what you're looking at, the rule for a quotient rule. Let's just dive in and do example 1, and it'll, of course, make more sense when we go ahead and do it. So move my screen down here a little bit for you. Let's do example 1. It says find the derivative. All right, so we got y equals this. Let's find the derivative. So I got y prime equals, and I'm just doing the quotient rule. It is low, the bottom function. So I'm just writing it down. And that is times d high. Low, d high. The derivative of the top, I'm just going to use the power rule to find it, and it's just 5. All right. And then minus, on this part now, minus high d low. So the high part is just 5x minus 2, the top function. And then times derivative of the bottom function. So I'm going to do the power rule again to this bottom function. So it's 2x plus 4. And then all that is over the bottom function squared. So I'm going to have this x squared plus 4x plus 1, all of that squared. And that's it. That's doing the quotient rule. Low, d high, minus high, d low, square the bottom, and away we go. All right, as far as the away we go part, usually that's the simplifying part. So let's go ahead and distribute this 5, and we'll distribute these two linear terms together, get a quadratic, and then we'll subtract them and all that stuff. So let's go through the algebra real fast. I'm going to distribute my 5, and I get 5x squared plus 20x plus 5. And be careful with this minus sign. I'm just going to leave it out in front for now. But when I distribute all of these together, and I get my 10x squared, and I get my minus, let's see, it'd be a minus 4x plus 20x. That'd give me a plus 16x. And then I'd get a minus 8 at the end. Well, here's where a lot of kids goof up, and they just leave that minus sign like that. Well, it's minus all of this. So make sure you keep it minus all of that. You mess up that negative, you're doing all this for nothing. All right, and then the bottom is still just squared. And I'm not even going to square that out. I'm just going to leave it like that, because if I square that out, it's not like a bunch of stuff will combine anyway. All right, but on the top, I do have a lot that will combine. I'm going to go ahead and take my 5x squared minus 10x squared, and I'm going to get negative 5x squared. I'm going to have a 20x minus 16x, and I'm going to get my plus 4x, and I'm going to have a 5 minus negative 8, which will give me plus 13, and all that is over my x squared plus 4x plus 1, all of that squared. All right, so there is my y prime, my derivative of y. And I could use this to, find the slope at any given point on this function right here. So the original gives you points that are on the line. The derivative gives you the slope at any point on the line, just to review that concept with you. All right, let's go ahead and do example 2 now. Example 2 makes us apply this a little bit. This one asks you to find the minimums and maximums of h of x. Okay, so here's our h of x. Now to find minimums and maximums, usually we're dependent on our calculator in honors pre-cal. Not anymore, because you know how to do derivatives. So we can find the mins and maxes without a calculator. And the reason that's important for you to be able to do is there is a non-calculator section of the AP Calc exam. I would say this one right here is easy enough. They would probably put this on the non-calculator section. So you got to find the minimums and maximums without a calculator. Okay. Well, just to review with you real quick, the calculus concept behind mins and maxes, okay, is just simply, I'll tell you, the graph of this would look like this. It looks something like this right here. It has slant asymptotes to it. It's really nasty. Okay, so we're trying to find this minimum right here, and we're trying to find that maximum right there. Well, the derivative of the slope of the tangent line at that point and at that point are both 0. Both of these have a slope of 0 at a min or a max. So what you're going to do is find the derivative of this equation, set it equal to 0, and then you'll find which points have a slope of 0. And that'll be your mins and maxes. So that's a huge calculus concept for you to get down early. All right, so let's find the mins and maxes to this thing. So I'm going to find the derivative. So I'm going to do h prime of x, and I'm going to go ahead and do my little jingle. Okay, low d high. So low d high, derivative of the top, which is just from the 3x squared, is going to be 6x. And then minus high d low. So high d low, derivative of the bottom is just 2. That's kind of nice. And then square the bottom, and away we go. Low d high minus high d low, square the bottom, and away we go. All right, so I'm going to go ahead and simplify the top down before I try to set it equal to 0, because it'll make my life easier. So I'm going to take the 6x, distribute it, and I'm going to get a 12x squared and a minus 42x, and I'm going to get a minus 6x squared out of multiplying these two together. And the bottom is still just that 2x minus 7 quantity squared. All right, I can put my x squareds together. Last thing I can do to simplify. So I'm going to get 6x squared minus 42x, and all that is still over 2x minus 7 quantity squared. All right, so there is my derivative. Now I'm looking for mins and maxes. So I'm going to say to myself, hey, mins and maxes, that's where the slope is 0. So I'm going to set this equal to 0, and then I'll go ahead and find the mins and maxes. So I'll put 0 equals this thing, this derivative, and that will allow me to find the x values that will have a slope of 0. All right, so when I solve this right here, I mean, you only need to solve the top, because, I mean, if you think of it as cross multiplication, if you want to, I'm going to have 1 times the top, 0 times the bottom. Well, I'm going to have 0 equal to the top, no matter how I think about it. So all I have to do is solve 0 equal to 6x squared minus 42x. And this is nice. The numbers work out nice. I can factor out a 6x and solve this no problem without a calculator. So 6x outside of, I'd have x minus 4. Oh, wow, not 42. Minus 7. There we go. All right. All right. And so I got my answers of x equals 0 and x equals 7. So there are my x values where this graph has a max and a min. All right. Now to find the y values, you got to put these numbers into the original function to get their y values. Okay. So I'm going to do h of 0, not h prime, h of 0. I'm going to put 0 into the original. Well, 0 squared is 0 times 3 is 0. And it'd be over -7. 0 over anything is 0. So my maximum right here was pretty dang easy. It's at 0, 0. All right, so here's my max. Now my min over here, I'm going to go ahead and put 7 into this function. So I'm going to do h of 7 and work that out real quick. Well, 3 times 7 squared would be 49. Times 3 would give me 147. And I would add 2 times 7, which would be 14 minus 7 is 7. So I'd have 149, or I'm sorry, 147 divided by 7. Well, that comes out 21. So my min is at 721. No longer do you have to sit there and search for windows forever on your calculator to find mins and maxes. Because we had graphed this in a standard window, we wouldn't even have solved this part of the graph at all because it's clear up at 21 up here. Okay, you'd have to sit there and search for a window, eventually find it. No more of that. You don't have to. You can do derivatives, set them equal to 0 to find mins and maxes. Okay. All right, let's go ahead and go to the other side. All right, now this one, example 3, I want you to learn how to avoid the quotient rule when you can. We're not even going to do this whole problem, but you can rewrite this to avoid the quotient rule. So what I would do right away on this one is set it up to do the product rule instead. So I could bring this is x to the 1/2, I can bring it to the top as x to the -1/2. So I'd rewrite this problem as 4x to the -1/2, and then I have sine of x. And then I would just put some parentheses in here so you can see that it's the product rule, and then I would do the product rule because the product rule is a little faster. Okay, first d last plus last d first. It's a little faster, so I would set this up as the product rule to save myself some time on the test or homework or whatever. So you can always, I shouldn't say you can always, you can sometimes avoid the quotient rule and go to the product rule, or go to the product rule by rewriting the problem. And the product rule is just faster because, again, you can do first d last plus last d first. Okay. All right, let's go ahead and do example 4 then. We're not going to finish example 3. We did product rule big time with Mrs. Pinion. You guys have that down cold. And besides, we're going to do the product rule right now. Example 4 says, find the derivative of this. Well, oh, crap. When we do the derivative of the top, we're going to have to do the product rule. So you're going to have the product rule inside of the quotient rule. I mean, this is awful. And this is when you start to become a really strong calculus student, is when you can combine rules inside of rules. Okay? It's almost like, I don't know if you've ever seen the movie Inception, where they have a dream inside of a dream inside of a dream. You'll end up with the quotient rule inside of the product rule inside of the chain rule by the time we're done with this. It's, wow, it's hard. It's a lot. Okay, but let's go ahead and attack this one. Let's find the derivative. So we've got f prime of x, and we're going to just, our overall rule here is the quotient rule because we have a top and a bottom. So I'm going to follow the quotient rule. Okay, low, d high. So I got to do the derivative of the top. This is where the product rule is going to come into play. All right, so I'm doing the derivative of the top, and I'm going to do the product rule to do that. So, oh my. So it's first d last. So first d last, which is just times 3, plus last d first. And that would be 2x plus 2. Oh my goodness. All right, and so we got first d last plus last d first. All I've done so far is taken care of low, d high in the quotient rule. And I have to do minus, high, d low. Oh goodness, I'm going to run out of room completely. So my high is all of that top. Sorry, this is totally running out of room. So I'll write it sideways, I guess. 3x plus 2. And then, so there's my high, d low. So all that would be times, the derivative of the bottom is actually nice. It's just 8x. All right. And then all of this is over the bottom squared. Oh, man, that's hard and that's awful. All right, but we could simplify this. I mean, we could distribute the 3 here, distribute these two, binomials together. We could put all this together and make a nice quadratic. Okay, and we could obviously put a lot of stuff together here. I'm not going through all that algebra because here's the beauty of the written part of the AP Calc exam. You do not have to simplify on the written part. So if this was on the written part of the AP Calc exam, you follow the steps to the quotient rule with the product rule inside of it, and then you go, done. And Mr. Miller will actually tell you, do not even attempt to simplify this on the written part because you might accidentally make an algebra mistake. So we're just going to leave it right there. All right, so there are your quotient rule notes. Tomorrow we will go ahead and we will have a notes page for you, or I'm sorry, a worksheet for you on this notes page. It'll be a pretty straight up quotient rule. And then on Friday, we'll give you just a couple problems, but they're going to be kind of beastly ones like this that have, product rule inside of the quotient rule, and maybe they'll have an application of find mins and maxes or something like that. All right, so you enjoy the rest of your day and take care.